The three important major modeling tasks in UML are structural modeling, behavioral modeling, and architectural modeling. In the last class, we had started talking about basic structural modeling in UML. So we have seen that basic structural modeling involves modeling the structure of the system, and the most important static structure of the system is the class. A class implements one or more interfaces, and we need to identify, in order to do the structural modeling, we need to identify the classes in the system that form the vocabulary of the system. Classes are used to model abstractions drawn from either the problem domain or from the technology used to implement a solution for the problem. We have given some techniques for modeling the vocabulary of the system, and first we need to identify those things that users or implementers use to describe either the problem or the implementation of the solution to the problem. For each such abstraction, we identify a set of responsibilities, and after doing so, we verify that each class is crisply defined. Once we have got the classes, we provide the attributes and operations that are needed to carry out these responsibilities for each class. It's also important to make sure that the classes are balanced. That is, no class is either too big or too small. If one class has too many responsibilities, possibly we should break it up into smaller classes. Or if a class is too small, maybe we will try to increase the responsibilities of the classes, so merge classes to make it bigger. Then we have also said that we can use packages to model clusters of classes that are conceptually and semantically related. And finally, we need to model the distribution of responsibilities in the system to make sure that all the classes are balanced. Today, we will look at some further tips for modeling a system, for structural modeling. So every class that you model in UML should map to some conceptual or some structural abstraction. Every class maps to some abstraction. The abstraction may be either tangible abstraction or a conceptual abstraction. And the abstraction must be either the domain of the problem, domain of the end user of the problem, or in the domain of the solution, what is of use to the implementer. So every class maps to some abstraction in the domain of either the end user or the implementer. And a well-defined, a well-structured class is one What are the characteristics that a well-structured class should have? Number one, it should provide a crisp abstraction of something from the problem domain or the solution domain. Number two, it must embody a small, well-defined, it must be crisp, it must embody a small and well-defined set of responsibilities. Number 3, it should provide a clean separation of the abstractions specification from its implementation. And finally, a class should be understandable and simple, but it also should be extensible and adaptable. It should be understandable and simple. At the same time, it needs to be extensible and adaptable. So in order to ensure this, when you draw classes in UML, you must show only the properties that are important to understanding the abstractions in its context. If a class has too many attributes or too many operations, it may not be necessary to show all these attributes and all these operations in all the class diagrams and all the views in UML. You need to elide or hide some portions which are not relevant to the abstraction that you have in mind. Secondly, you must organize, if you have to have a long list of attributes and operations, you must organize these lists of attributes and operations. Organize long lists of attributes, operations by grouping them according to their category. And thirdly, you should show the related classes in a class diagram. A class diagram should contain all the classes which are related to each other. In order to show all the classes in the system, you may use more than one class diagram. But you should show all the related classes in the same class diagram. Now, after we have modeled the classes, we have to find out the relationships that exist between the classes. So, relationships are used for connecting classes. And we will see that the three important types of relationships that we will consider are: number one, dependencies or using relationship. Number 2, generalizations or is a relationship, is a or inheritance relationship. Number 3, associations or structural relationship. Dependency or using relationship can be like this. Suppose you have an object account which has an attribute balance which is of type money. So there is a dependency relationship from that class, the class account, to the class money, which is denoted by this symbol. A generalization relationship is denoted by an arrow from the child to the parent. And the association relationship is denoted by a link between the two associated classes. Suppose we have these two objects, company and person, and the person works for company. We can have the works for association from the person to the company. And the company is the employer, the person is the employee. So, since very few of your classes stand alone, it is very important to model the relationships that connect these classes. And in order to get the total model of the system, you need to look at the vocabulary as well as the relationships. So before we go further into these things, we will look at an example class diagram which uses these different relationships. So we have, let us say, this object window, which has the following operations: open, close, move, and handle event. We have another class whose name is event, and we have different types of windows. For example, we have a console window, and we have a dialog box, which is another kind of window. And we have a control, which is a class that is part of our implementation. Now let us see what are the relationships that exist between these classes. Firstly, there is a dependency relationship from window to event, as a window changes depending on the event. So this is a dependency relationship. Then we have inheritance relationship, a generalization relationship between console window and dialog box and window. So these are generalization relationships. And thirdly, the dialog box, there is an association relationship between dialog box and control. Now, we will look at these relationships into a little more detail. first we take up dependency relationship or using relationship. So dependency relationship states that a change in specification of one object may affect the other object. A change in specification of one thing, for example, in the earlier class diagram, a change in specification of the event may affect another thing that uses it. In the example given before, a window is affected by a change in event. Secondly, let us look at generalization relationship. Generalization is a relation between a generalized thing and a specialized thing. A relation between a general thing and a more specific kind of that thing. Generalization is most commonly used among classes and interfaces. However, UML also uses generalization among other things, most notably among packages. So generalization is applicable to classes, interfaces, packages, etc. Thirdly, we come to the association relationship. So association is a structural relationship so it specifies that objects of one thing are connected to the objects of another thing. And there are 4 adornments that apply to associations. These adornments are name, role, multiplicity, and aggregation. We will illustrate this by an example. Suppose we have this object company and 2 other objects, department and person. There is an association relationship between company and department as well as that between company and person. And since a company consists of departments, so the relationship between a company and a department is also an aggregation relationship or a whole part relationship. So this is denoted by this sort of link, and we specify the multiplicity of this relationship by writing that this is a 1 to star relationship. A department can consist, a company consists of 0 or more departments. And we also have a relationship between company and a person. And this is the works for relationship. A person works for a company. This is a works for relationship, and so the name of this relationship is works for, and the direction is in from person to company. A person works for company. So this works for is the name of the relationship. This arrow is the name direction. And if we say that the multiplicity of this relation is like this, company 1 to 1 dot dot star. A company consists of 1 or more people. So this is a 1 to many relationship. So this is the multiplicity of the relationship. So name, direction, multiplicity. There are other adornments also possible. For example, instead of giving the name of to the relationship, we can give the roles of the different things that are connected to this relationship. For example, the company-person relationship can alternately be written like this. So we have a relationship and we say that the role of the company is the employer and the role of the person is the employee. So we write employee on this end, the employer on that end. So we have looked at 4 types of adornments. One is the aggregation adornment, the name, the role, and the multiplicity. Now we come to some common modeling techniques, the ways of modeling the structural relationship. First, we come to modeling simple dependencies. So the most common kind of dependency relationship is one where one object occurs occurs in another object as a parameter. So the most common kind of dependency relationship is a connection between a class that only uses another class as a parameter to an operation. In this case, we can identify that there is a relationship, dependency relationship from the first class to the class that is being used as the parameter. Secondly, let us look at how to model single inheritance. In order to model inheritance, we have to identify the hierarchies present in the classes, and we can do so by following a number of steps. So this is used to model inheritance relationships. Let us look at the steps that we can carry out. Firstly, given a set of classes, we look for responsibilities, attributes, and operations that are common to two or more classes. Secondly, we elevate these common responsibilities, attributes, and operations to a more general class. Thirdly, if necessary, we create a new class. And to this new class, you can assign these elements. Finally, specify that the more specific class inherits from the more general class by placing a generalization relationship that is drawn from the specialized class to the generalized class or the parent. So let us look back at the steps. First, when we are given a set of classes, we look for responsibilities, attributes, and operations that are common to two or more classes. After having identified these common responsibilities, attributes, and operations, we elevate these common responsibilities, attributes, and operations to a more general class. If necessary, we create a new class to which we can assign these elements. And we will see that often this new class may be an abstract class as opposed to a concrete class. More of that later. Finally, we specify that the more specific class inherits from the more general class by placing a generalization relationship from the specific class to the more general parent. Now, we will illustrate this by another class diagram. So let us say that we have four types of objects: cash account, stock, bond, and property. And these objects have certain attributes and relations which are defined on them. For example, for all these objects, we have two operations defined. Number one is present value, number two is history. Now, suppose the history, the operation history, which is defined on all these four objects, is carried out in the same way, whereas the operation present value has different implementations for each of these objects. Now, what we can do is create so since we note that present value and history are common between these four objects, we create a new class called security, which is an abstract class. And security will have the operations present value and history defined. Note that we have written security and present value in italics. So this denotes that security is an abstract class. There is no in the system, there will be no object of the class security. But the definition of security provides an interface, and all objects that are subclasses of the class security must implement this interface. Also, this operation present value is written in italics. It means that this is an abstract operation. The implementation of this operation is not provided in the definition of the object security, but these subclasses of security must define the implementation of this operation. History is an operation which is a concrete operation for which the method will be defined in the class security. So, we have all these four classes inheriting from the abstract class security. And so now suppose that we have two more classes which are subclasses of stock. For example, we have a small cap stock and large capital stock. And we note that the small cap stock and large cap stock are subclasses of a concrete class stock, and we can represent this by a inheritance relationship. So we note that an abstract class is denoted by italics, whereas a concrete class is denoted by normal letters. An abstract class is an incomplete class, and there can be no objects of an abstract class. and these are all concrete classes. Abstract operations are also denoted in italics, and abstract operations means that the implementation of the operation will not occur within the class. An abstract operation provides a signature. An abstract operation provides a signature, and it must be implemented by some method in the lower levels of abstraction. Must be implemented by some subclasses in the lower levels of abstraction. Now, let us see how we can model structural relationships. First, we note that the association relationship specifies a structural path across which objects of the classes interact. Now, to model these structural relationships, number one, for each pair of classes, if you need to navigate from objects of one to objects of another, you specify an association between the two. Specify an association between the two. This process, as you can see, is mainly data driven. Secondly, if objects of one class needs to interact with objects of the other class, other than as parameters to an association, other than as parameters to an operation. If the one class occurs as the parameter to an operation of another class, there will be a dependency relationship between the classes. Then you specify an association. This process, as you can see, is behavior driven. That is, for each pair, if there is a need to navigate from objects of one to that of another, you specify an association between the two classes. And if objects of one class needs to interact with objects of the other class other than as parameters to an operation, you also specify an association. This is behavior driven, the former is data driven. Thirdly, for each class, you specify the multiplicity as well as the multiplicity of the association operation as well as the role names. The default multiplicity is star. Fourthly, if one of the classes is a whole and the other class is a part of that whole, mark this as an aggregation relationship. Let us look at an example of this. We have these objects: a school, then we have departments, we have student, of course, and we have another object, instructor. Now you can see that there is a relationship between school and department, which is an aggregation relationship. So this is a school has departments. The name of this relationship is has. Similarly, there is also an aggregation relationship between school and student, and the name of this relationship is member. And the direction is in this way. Here also we may put the direction in this manner, and we can give the multiplicity of the relationship. And then there will be relationship between the object student and the object course, because the student attends the courses. And there will be a relationship between course and instructor. An instructor teaches the course. Name of the relationship is teach, and one instructor teaches 0 or more courses. A course is taught by 1 or more instructors. And so the multiplicity here is star, and here it is 1 to star, 1 or many. Then there will be a relationship between department and instructor. A department has a number of instructors. An instructor is assigned to a department. And a department has one chairperson, and the chairperson is an instructor. So there is the chairperson relationship between one instructor and the department. So this is that relationship, and the role of the instructor here is the chairperson. So we will stop here today. In the next class, we will take up the further aspects of structural modeling, and after that we will later move on to behavioral modeling. Thank you.